Yes, good morning to all.
Morning, sir.
Yeah, am I audible? Yes. Okay, thank you. Yesterday, we finished understanding how to delete from the front and how to delete from the rear end from the doubly linked list. Okay, so circular doubly linked list with the header node. So now, time to understand the circular singly linked list. Okay, circular linked list, and we'll start it. Okay, so now what we are going to discuss here. So we'll understand what is a circular linked list is, and how the circular linked list is different from the linear linked list and the circular. Okay, the difference between the linear linked list and the circular linked list. So this is what we understand, and then we focus on the different types of circular linked list, and one type we have already discussed. So both the types we have already discussed it. We are going to discuss. So because circular doubly linked list I was mentioning, and that is one type, and which you already know. Okay, and then we look into the advantages of the circular linked list. So what are its disadvantages at the same time, and so what are the operations that you can perform on the circular linked list. So these are the things what we will be covering in the today's class. So now, structure of the linked list, as you all know. Okay, so it's something like this. When you look into the linked list, a normal linked list, this is how it looks. This is a normal linked list. I'm not talking about the circular linked list or the doubly linked list. It is a normal list, or the you can say linear list. So we have an head node, and followed by that is a node which is containing the data, and finally this is the last node. So how do I say this is the last node? Because the last node is attached with the null. Okay, and basically a node in a single linked list has two types, two fields, two major fields. One is the info field, another one is the next field, and all these things you know. So one node is made up of two parts. So this is one part and this is another part. Some data that it holds, and a reference to the next node. Okay, so this is the data, the actual information what the node is holding, and the other one is to point to the next node. So point to the next node which is holding the actual data. Okay, so and this is all of you are familiar with. Okay, all of you are already familiar with these things. Okay, so this arrow here itself is what the address of the next node. Okay, and this is the node, and if you zoom into this node, it has two fields, something like this. So even if you have more than one field, you can go for having any number of fields here. Okay. Now, what is a circular linked list? Is a variation of the linked list or the linear linked list, in which the first element points to the next element and the last element points to the first element. Okay, so in which the first element points to the next element and the last element points to the first element. Okay. So both singly and doubly linked list can be made into a circular linked list. So that is what we have understood. Singly linked list you have understood, and after that we understood the doubly linked list. There you know how to make it as circular, how to make a doubly linked list circular. So using the header node we made it as circular. So both, even the singly linked list also you can take it and you can make it as what a circular. Okay, and circular list. So why we are making the singly or doubly linked list as a circular list? Because it helps traverse the same list again and again if needed. Okay, so if I say I have only a linear singly linked list, or just a simply a doubly linked list, I can traverse only one time. Say singly linked list, if it's a linear singly linked list, I can start from the starting node, I can traverse till I reach the end. So then my journey ends there. It is not possible for me to traverse again using the same pointer. Okay, so I got to take one more pointer and initialize it back to the start, and then I have to start traversing. So it is not possible for me to repeatedly traverse the same list again and again in case of a linear singly linked list. So if I convert that linear singly linked list into a circular singly linked list, it is possible for me to repeat or traverse the same list again and again, so by using the same pointer without the need for any additional pointers. Okay, and in case if you make a doubly linked list as circular, so using one single pointer, it is possible for you to repeatedly traverse the same doubly linked list again and again in both the direction, in clockwise direction and also in the anti-clockwise direction. So that flexibility you'll have. So but whereas in case of a singly circular list, so you can traverse the list again and again, so but not in both the direction. So either you can go for traversing it in the clockwise direction or in the anti-clockwise direction, but both the direction is not at all possible. Okay, OP people are following? Am I audible clearly?
Yes, sir.
Okay. Yeah, thank you. So now as an example we have this. Okay, so what you're seeing here in the example is a circular singly linked list. Okay, so I have the head. Okay, so this is the pointer, so you can see star over here which is pointing to this node. So since I say this is pointing to this node, so what is the address of this node? See, I have written here, address of this node is printed on top of this node. So 1001 is the address of this node, and so the value of the head is also 1001. It's nothing but the pointer head is right now pointing to this node. Okay, and then this is the next node again. Now, so there is a link from this first node to this node. So you can see the address of this node, that is 1004, in the link field of the first node. Okay, and then info field of the second node is 15, and the link field of this node is storing 1008, which is the address of the next node. So it's, and finally when you go to the last node, instead of storing null over here, correct, so what we are storing is, we are storing the address of the first node. That means even from the last node I can easily get back to the first node. And in what is the direction of traverse here? So I can traverse the list only in the clockwise direction. So the opposite direction traversal is not at all possible. But how many times I can traverse in the clockwise direction? Any number of times repeatedly you can keep doing this without using the additional pointer. Only just by using the head pointer it is possible for you to repeatedly traverse this list again and again. So this is the simple representation which you already know. Say for example the fun fact. What is the fun fact here? So if you are worried about its implementation, it is not at all a difficult thing. If you know how to implement a singly linked list, so you can easily convert it into a circular singly linked list. Now how to do that? Only this change. So instead of storing null in the link field of the last node, you got to store the address of the first node. So if you are doing that, so you have a circular singly linked list. Okay, so implementing or just enhancing a singly linked list to a kind of circular linked list is not at all difficult, and it is very easy, and you can do it without any additional effort. So that's what is written here. Okay, so placing null at the last node field, you can place the address of very first node. So if you place the address of the very first node here, so you have a singly linked list converted into a circular singly linked list. So now time to understand the circular linked list versus the linear linked list. Okay, so Now when you are going to use the circular linked list, so circular linked list is a natural option to represent the arrays that are naturally circular. Say for example, so I want to represent the corners of the polygon. When I say polygon, all corners are connected, correct? No? So then you can go for using the circular linked list, correct? Because ultimately all corners of the polygon are connected. A pool of buffers that are used and released in FIFO order. So first in, first out order. Say for example, I want to make that we have a data structure called as pipes. Later you'll understand when you go to the higher semesters. Correct? There is something called as a special pipe called as, so special file called as pipe. Now using pipes, you can go for making two processes communicate. So where one process will keep the data, keep writing the data to one end of the pipe, and other process will keep reading the data from the other end of the pipe. And how this communication happens? It happens in the FIFO order, first in, first out order. So whoever writes first, the data that is written first by the writer process will be the one to be consumed first by the reader process. Okay, so it happens in the first in, first out order. Whatever the writer writes first will be the first to be consumed by the reader process. And to implement this, what you require is a circular singly linked list. Okay, or the set of processes that should be time shared. Say for example, I don't know whether you people are studying the operating system subjects now. So if you're studying the operating system subjects now, or if you're not studying now, or in the higher semesters, you'll understand. So there is something called a CPU scheduling algorithm. Even the CPU scheduling algorithm also uses the circular linked list. Now what it will do, all the ready processes, all the processes which are ready to be executed will be kept in the form of a circular singly linked list. So the first process which is ready for execution will be there waiting at the front end of the queue. So CPU will pick that process, performs the execution for some time slice or the time period, and immediately it will switch to the next process in the queue. Okay, so this. Hope you people are following. Hope you understood with the first point.
Yes, sir.
Yeah.
Yes, sir.
Yeah. So with a circular list, and then the second one, with a circular list, a pointer to the last node, okay, gives access, easy access also to the first node. So if you have a pointer pointing to the last node, so using that pointer you can easily access the first node by following one link. So just by one link. So for example, I have a pointer PTR pointing to the last node. So if I need to access the first node, it is easy. So I just need to follow one link. What is that? So PTR. So PTR arrow link. So PTR arrow link will make me point back to the first node. So thus, in application that require access to both ends of the list, a circular structure allows one to handle the structure by a single pointer instead of two. Okay, this. Hope you people understood. So if you want to handle both the ends, so then it's better to use a circular list. Okay, and how do we represent an empty circular list? Okay, so and that is again by using a null pointer. Okay, so you can take an header node. So a null is nothing but what? Say pointer is currently null. What does it mean? So a circular linked list is empty. So if you are trying to implement a circular linked list by using an header node, now how do you represent an empty circular linked list? So header node link field, or the header node next field should be made to point to itself. So I'll just write and show you. So I opened this here with the browser just for writing, because I can easily write using this. Say for example, I have an header node to the circular singly linked list. So say this is the header node. It is pointing to this. Now how do I represent an empty list? So this link field, make it point back to itself. Okay, so link field here, you store the address of the same node. So and that is nothing but what? The empty circular linked list. Hope you people understood with this. Is that clear?
Yes, sir.
Yeah. Now, types of circular linked list. One is singly linked list, another one is doubly linked list. Okay. So the last node here. So singly linked list, because it can be traversed in only one direction and any number of times you can do it. So this is the example for the singly linked list, and this is the example for the doubly linked list. So but this list, how it is different from the doubly linked list that we understood in the previous class. So in the previous class we understood the doubly linked list with an header node. Right now there is no header node. We don't have the header node present here. So what we have is a simple doubly linked list without the header node. So I'll come to this later. So this is the example for the first type of circular linked list. So circular singly linked list it is. Okay. So where the link field of the last node is holding the address of the first node. So I hope this is clear. Next. So doubly linked list without the header node. So two fields are there, left link and then the right link, left link and then the right link again, all these things. So since there is no header node here, you can see here the right link of the last node is holding the address of the first node, okay, and the left link of the first node is holding the address of the last node. So that means, so now what is the difference between this and this? Here you can repeatedly traverse only in one direction, but here you can repeatedly traverse the list or doubly linked list in both the direction, either in the clockwise direction or in the anti-clockwise direction. OP people understood this? This is same as what we understood in the previous class, but without the header node. We don't have the header node here. Is that clear?
Yes, sir.
Yeah.
Yes, sir.
Now, how do you represent an empty circular singly linked list here? So like this. I'll show you. Say for example, with the header node, if I'm so here, I have to just say it as null. So if the list is null, so I say it is empty. And here also, if there are no nodes, so the pointer will be equal to null. I say it is empty. So if I'm using the header node, so if there is an header node, always header node will be there, correct? And if there are no nodes, so the link field of the header node will be pointing back to itself. Okay. So if you are implementing a circular linked list with a header node, this is how we represent an empty circular singly linked list. If you are implementing a circular linked list without the header node, something like this, then null itself is sufficient to say whether it is empty or not empty. And similarly, in case of a doubly linked list, if you are implementing it like this without the header node, so then null is sufficient to say whether the doubly linked list is empty or not empty. Now, if you are implementing it with the header node, okay, so I say this is the header node. What you have to do? You have to make your right link of the node to point to itself, and the left link also to point to itself. So this is how you make represent an empty circular doubly linked list in case of the header node, if you are representing it using the header node. OP people understood?
Yes, sir.
Okay. Okay. Now advantages of the circular linked list. Okay. Any node can be the starting point. This is the best advantage and very good advantage of the circular linked list. Any node can be a starting point. Why? I'll tell you. Say this is a circular list. Say I have a pointer pointing to this. Okay. I don't have any pointer pointing here. I have a pointer pointing to this node. Yes. So this can be a starting point, and from this point you can go for traversing all the nodes. So if I assume this is not a circular linked list, okay, so if I assume the pointer is pointing here, is it possible for me to traverse and reach these nodes? It is not at all possible. If it is not a circular kind of list, and if I have a pointer pointing to this node, so then it is not at all possible for me to reach this node and this node. I can reach all the nodes only if the pointer is pointing to this. If this must be the starting point for a non-circular singly linked list. But for a circular singly linked list, so the any node can be the starting point. Okay, that is what the meaning of this point is. So we can traverse the whole list by starting from any point. We just need to stop when the first visited node is visited again. Okay, so that is. Hope this statement or advantage is very clear to you people. And the second important advantage is that the circular list is useful in application to repeatedly go around the list. So for example, so when multiple applications or multiple processes are running on the PC, even the operating system, your OS or the operating system will put all those processes in the form of a circular list and will go for executing the processes one after the other in the FIFO order, first in first out order. So this, I think, the point I also highlighted in the previous slide. Okay, that is, even the operating system also makes use of the circular list concept just to place all the processes which are ready for execution and to perform the execution of them in the FIFO order. Okay, and even the circular doubly linked list, which we understood in the previous class, are widely used in the implementation of advanced data structures like Fibonacci heap. So, and again, so we'll be discussing more on this data structure in the 5th module. Okay. So these were few advantages of the circular singly linked list. Okay, singly linked list and circular doubly linked list. Now, okay, advantages you understood. The same time, we do have the disadvantages also. Circular linked list disadvantages. So depending on the implementation, inserting at the start of the list would require doing a search for the last node, which would be expensive. Okay, say so it depends on implementation, how you are implementing, because yesterday we understood the implementation of inserting at the front, inserting at the rear, deleting from the front and deleting from the front end. All these things we did. But when it comes to the question of circular singly linked list, okay, say for example, I want to delete this node. See, so this node I need to delete, the first node I want to delete. Now what is that I have to do now? See, I'll be having a pointer pointing to this. Let me say it is a start. Start is pointing to this. Okay. Now when I delete this, so I have to make start to point this node, and this link which was pointing here should be made to point to this node. Okay. In order to make the hold or store the address of this node here, what is required? Can you store the address of this will become the next starting node. So that is easy. You can just do start is equal to start arrow next. Start will point to this, but you got to change this now. So this link which was pointing to this node, you have to make it to point to this node. Is it possible for you to do this last node pointing to this node without having a pointer here? Can you people do without having a pointer here? Yes, tell me. See, yesterday we did it because it was a doubly linked list. Even from using this node, it was possible for you to reach this node. Now this is a circular singly linked list. Using start, is it possible for you to reach directly this last node?
No, sir.
Not possible. Now that is the disadvantage here. That means you got to start from the start node and keep traversing all the nodes of the list until you reach the last node. Correct? No? You should every time you jump to the next node, you got to check whether it is the last node. If it is not the last node, again you got to jump. So and check whether it is the last node. No, it is not the last node. Jump again. So check whether it is the last node. Yes, if it is the last node, you have to make the pointer stop there. And now using this pointer, you can go for say for example, I make PTR to stop here. Okay, I have started PTR all the way from the start, and every time it jumps, I was just checking whether it is the last node. So this checking I got to do it. So, and when PTR is pointing to this, I check, is it the last node? Yes, it is the last node. Now what I have to do? Now PTR arrow, now I have access to the last node. Now I have to say PTR arrow link. So because this is the link field, PTR arrow link is equal to what? Is equal to what? So before doing this, I have to say start is equal to any of. So when I'm deleting this node, start should not point to this, start should point to this. So I'll be doing that by saying start is equal to start arrow link. When I do this, start is not pointing to this, start is pointing to this. And next, if I say PTR arrow link is equal to start, what happens? So this link is broken, and the last node here, it just points to this. Hope you people understood?
Yes, sir.
Yeah. So that means whenever you got to delete a node or insert a node, so it is not at all possible by using just one pointer, that is start. You require one more additional pointer. One more additional pointer is required, and that pointer again will be starting from the starting node and will make that pointer to traverse till it reaches the end of the node. Every time it is traversing, you got to check whether the pointer has reached the end of the node or the beginning of the node. Okay, so that is one disadvantage. But in the previous class, we understood doubly linked list, and we never took a pointer and we made it to what? Traverse. Hope you people understood. So just we using the head was pointing to the starting node. Using that, it was possible for us to insert at the beginning and insert at the end without the need for an additional pointer. Okay. So advantages, and hope the first disadvantage you understood. Inserting at start of the list would require doing a search for the last node, which could be expensive. Now what is the meaning of expensive here? Every time the additional pointer which you are taking, it traverses the next node, you got to check, you got to do an additional computation there. What is that additional computation you are doing? Checking whether it is the last node, and that consumes a lot of CPU cycles, and we say it is expensive. Okay, and finding the end of the list and loop control is harder. Okay, because no null to mark the beginning and the end. In case of the singly circular list, so if it is just a singly linked list, so the last, if it is not circular, the last node will be storing what? The null. So if the link field of a node is null, what does it mean? It is the last node. So we can easily understand. But in a circular linked list, it is not that easy, because the nodes are not marked with the beginning null and ending null. Yeah. So operations on singly circular linked list. What are the operations you can do? You can do all these operations. Even we understood these operations on the doubly circular linked list. Now we focus on these operations on the singly circular list. How do we perform the insertion to the singly circular list? How do we perform the deletion from the singly circular list? And how do we go for displaying all the nodes of the singly circular linked list? Okay. When I say insertion, all possible things we discuss. How do we insert at the front end to the singly circular list? How do we insert at the rear end to the singly circular list? How do we insert in the middle of the singly circular list? And inserting in the middle of the singly circular list is exactly same as what? Your singly linked list. Okay, that I need not explain. And deletion. So inserting, how do we insert at the singly circular list? Front of the singly circular list. How do we insert at the rear end of the singly circular list? And deletion in the middle of the singly circular list is exactly same as deleting from a normal singly linked list. Hope you people are understanding what I'm telling?
Yes, sir.
Okay. And then we also understand how to display. Okay. So now we'll just talk about discuss on the insertion part. So 3 types of insertions are possible. First insertion, inserting at the last. First insertion is nothing but inserting at the front of the singly circular list. And when I say insert at the last, inserting at the rear end of the singly circular list. And insert after constant is nothing but inserting at the middle of the singly circular list. Now insertion after the constant and circular linked list is same as the linear singly linked list, is exactly same as the linear linked list. That's why we don't discuss this third part. Okay. See, if you just look into the middle portion of the singly circular list, it is exactly same as what. So just forget this end and forget this end. Just focus on this part, the middle part. How it looks, it's same as what? Exactly same as the normal singly linked list. Okay. So the where will be the difference? Difference will be here when you are inserting at the beginning, and when you are inserting at the rear, when you are deleting at the beginning, and when you are deleting at the rear. So the difference is there, but inserting and deleting from the middle is exactly same as the linear singly linked list. Okay. So that is what this note is conveying. Okay. So I hope you people understood the importance of this note.
Yes, sir.
Yeah. Now, how do we insert at the front? Okay. Just observe. This is my singly circular list. How many nodes I have? 1, 2, 3, 4 nodes I have, and start is pointing to this. Start is pointing to this. Now I need to perform insertion at the first or insertion at the front. Now what I have done, so I have taken an additional pointer. So A is the address of this node, and B is the address of. Instead of taking the numerical values, alphabets are taken here. I think it will not confuse you. So this is the info field, and this is the address field. So address of this node is stored here, and address of this node is stored here. Address of this node D is stored here, and the address of the first node is stored here, that is A, and A is the address of this node, and the one which I have written inside the bracket is T. It's a temporary pointer which is taken, and we have made T also to point to the node to which start is pointing, and you know how to do it. It's very easy. All you need to do is T is equal to start. So T is equal to start. Okay, T is also pointing to this. I hope you know now, why we are taking an additional pointer. So it is not possible for you to perform insert at the beginning until and unless you take a pointer which is pointing to the last node of the singly circular list. Now I need to make this T travel and reach the last node. Correct, right? So this you understood, right?
Yes, sir.
Yeah. Next, what I have done, so I have created the node to be inserted. So this is the node. So this is the node which I need to insert now at the beginning, and who is pointing to it? Yeah, what is the pointer that is pointing to the node, newly created node?
P
is pointing. P is pointing. Okay. So now, so this node is created. Now what is that I need to do? Now I need to make my T travel all the way to the last node. Correct, right? So this is how I am doing it. While T arrow next not equal to start. Sorry. So I think not is not visible. So there is a not here. In the next slide, I have the algorithm also. I'll show you. Okay. Do I need to zoom it, or is that sufficient?
Sufficient.
Okay. See, while t arrow next not equal to null. So instead of link, I've taken next here. That's all. Don't confuse. Link next is same. T arrow next not equal to start. Okay. So t is pointing to this right now. Correct, right? Yes or no?
Yes, sir.
Now what I'm checking, t arrow next. T arrow next, is it null? No, not null. Now what I do, t is equal to t arrow next. So t just points to what? B. So t was pointing to this node. Now after this statement executed, so t is pointing to this. Now again I go back to the while. Okay, t is pointing to this. Let me write here. Again I go back to the while loop. T arrow next not equal to start. T arrow next is how much now? C. C is not same as what? Start. C, this is C not equal to A. True. So again t is made to travel. T is equal to t arrow next. So we have t not pointing to this and t is pointing to this. So this is expensive. Okay, every time you make the t to travel to the next node, you are checking whether it is not the start. Okay, now again t arrow next not equal to start. Okay, t arrow next is how much now? D. D not equal to A. True. So again you got to make t travel one more node. So t is not pointing to this, t is pointing to this. Now you observe t arrow next, how much it is? What is t arrow next? A it is. A not equal to, what is the start value? A.
Yeah.
A not equal to A. Condition is false. That means, so once the condition becomes false, so it indicates t has reached the last node. So t is now pointing to the last node. That is what I have written, d of t. So t is pointing to the last node. Now the while loop gets terminated. Next, what I have to do? Observe here. So now I got to store address of this new node. Correct, right? Yes or no?
Yes, sir.
Address of this new node in the next field of the last node. Right now t is pointing to the last node. Now I have the easy access. How to do it? So t arrow next is equal to what? P. Because P is the address of the new node. Yes or no? So now P is stored here. That means from this node, from this last node to which T is pointing, you can reach this new node which is created. But still you need to establish this link. Yes or no? Now how to do this? P arrow next. See, and sorry, before this I have to say, start is pointing to this. Okay, so correct, what I was writing is correct. So P arrow next is equal to what? Start, because start is still pointing to this itself. START. Is it clear? Now this link is established. When I say this, P arrow next is equal to start. And after this you got to do one more statement. What is it? Yeah. See, start is pointing to this, but start should be always start should be always pointing to this node now. I have to make start to point to this. How do I make it? How to make start to point to this? Yeah, louder please. Your voice is breaking. Now, is it P is equal to start or start is equal to P? If you say P is equal to start, even P also goes and points to this. Now, I don't want to make P to point to this. What I want to do is I want to make start to point to this. How to do that? Start is equal to P. Okay, you told it reverse. you got to do it as start is equal to P. Is that clear?
Yes, sir.
Okay. So the whole process you understood. Yes or no? How to insert at the beginning of a given singly circular list. What you have to do is you got to take a temporary pointer, make it to point to the start node, create the new node, and then make your temporary pointer travel the singly circular list until it reaches the last node. The moment it reaches the last node, so you go for updating the next field of the last node with the address of the newly created node, and after doing this, from the in the next field of the newly created node, store the address of the starting node, and then make the start to point to the newly created node. OP people understood?
Yes, sir.
Okay. Now for the same thing. So this was diagrammatical representation and how to do that programmatically with all this explanation. So now this algorithm you can easily understand. Now what you are seeing, let me reduce it a little bit.
Sir.
Yeah?
Sir.
Tell me. Yeah, tell me.
Sir, why we are not storing the address of A in P?
One second. Address of what? Address of?
A.
A itself is the address.
Oh, okay.
A itself is the address. A is the address. A is the address of this node. Yeah, tell me what is your doubt?
In second node, sir.
Yeah.
The last.
Here.
Yes, sir.
Okay. Okay. I got your point. Why you're asking why is this X? Okay.
Yes,
so
sir.
this was not known. Sorry, it does not update here. Good. Thank you. So this is A. It becomes A. See, earlier when you create the node for the first time, okay. So what is that you'll be storing? Null you'll be storing here. This X is nothing but null now. Thank you, man. Very good question. So this X is nothing but null here. Now it is still null here. The moment I do this, which one? P arrow next is equal to start. So we have A stored here, and then this is also A. Correct? Yes or no? And this is not A here, sorry.
Yes, sir.
This is P. Address of this node. And start is pointing to this. OP people understood.
Yes, sir.
Address of this node is still A. This is A. And this address is stored here. And initially when you create this new node, this X is nothing but what? So X is indicating it as the next field of the newly created node is temporarily set to null. Correct, right?
Yes, sir.
Okay. Now, so this is the algorithm. Now, what we are doing, we are starting. So we create a temporary pointer. Now to do that, struct node start t temporary pointer, and we make this temporary pointer point to the start same node, and then go for creating a new node. Now how to create? We got to make use of the malloc function and enter the information part. Okay, and information part, and also set the next field to null. Okay, next field information part you define, or the data part you define like this. So new node created, so data you are defining, and the next field is set to null. Set the next field to null and check if start is equal to null, and then set start is equal to n, and set start arrow next is equal to start, else n is equal to n arrow next is equal to start. So if start is null, what does it mean? The circular linked list is empty. You make start as what? The new node. N is nothing but the new node which is created. So new node we are calling, see, new node we are calling it as what? N. So make start as the new node. So if start is not null, okay, start as new node and start arrow next is equal to start. So that is what I said. See, this is the node which you have created. Say list was empty, Okay, so what you do, n is pointing to this. If the list is empty, so we make start also as n. So start is pointing to this, and then, so this is the node now. So since there are no more nodes, so I got to make this as circular now. This is the first node in the circular list. So the link field should hold what? Start arrow next is equal to start. That means we are making it to point to itself. So this is the status of a singly circular list with one node. OP people understood?
Yes, sir.
Yeah. And then otherwise, if start is not null, what does it mean? There is an already existing circular linked list. What you have to do is set n is equal to n arrow new node arrow next field is equal to what? Start. Okay, and then this, repeat this step here. So this is what I'm showing you now, this while loop. While t arrow next not equal to start, make t to travel. Once t reaches the end, set t arrow next is equal to new node and make start as what? N. Hope you people understood with this algorithm. So same thing what I explained here written in the form of the steps, and here in the form of the program. So I hope the algorithm part is clear.
Yes, sir.
Okay. Now we'll just look into the program, actual program. So function. See, I've taken a temporary pointer t and I've made it to point to the same node to which the start is pointing, and then creating the new node by using the malloc function, and n is pointing to it. Reading the information field, storing it into the info field of the new node n, and then I'm checking if start is equal to null, checking whether the list is already empty. If the list is already empty, I make start to point to the newly created node, and the next field of the start is made to point to itself, like this. Okay, next, else what I'm doing, so next field of the new node is made to start. I'm storing the address of the starting node in the next field of the new node, and then I make my temporary pointer t to travel until it reaches the last node. Once it reaches the last node, I make the next field of t field is equal to the new node and start is equal to n. I hope it's very clear. Yes or no?
Yes, sir.
Okay. So we'll stop
Yes,
here,
sir.
and tomorrow we'll understand how do we perform insert at the last, okay, to a circular singly linked list. Okay, let me stop here.